Hey guys, today we are going to do, let me put my timer. Today we're going to do relative extrema. Relative extrema. I'm trying to find an easier way to teach this. So relative extrema. Okay. So what does this mean? So this means we're going to be finding, I'm just going to put REL for relative. So we're going to be finding a relative max, a relative mean, and then we're going to find intervals, interval where the function is increasing or decreasing, or both, right? Okay, this is what we're doing today. Um, the first thing that I'm going to talk about is also something new that we're gonna learn today is called critical points. Critical points, or they also call them critical numbers. Critical, can you guys see? Oh, there. So critical points or critical numbers. Okay. Okay. So a critical point happens when your function, when a function, I'm just gonna put f of x. So when a function changes from increasing to decreasing, or the other way around, decreasing to increasing. Okay, this is what happened. How do you find a critical number? We're gonna do it right now. So it happens usually when your derivative is equal to 0 or undefined. Okay, that's what happens. So let me give you an example. If you remember from your algebra 1 or algebra 2 or IM3 class, you learn the graphs, the parent functions. So y equals x squared looks like this, right? Okay. If you look at this, the minimum point is right here, right? Because that's the minimum point. Okay. So when we say when the derivative changes from increasing to decreasing, in this case it changes from decreasing to increasing. Okay. Let me explain this. This is a relative mean, a relative minimum. How do we know? Because this is the minimum right here. That's the minimum point. Okay. If we talk about a derivative, let me use this. No, let me use this one. I'm gonna do some. I'm gonna do some. What do you call it? Advertising right now. There you go. All right. So look, this is gonna be like my ruler. This is your derivative. Remember, a derivative is a slope at a point. So if I want to find the slope at this point, I just find the tangent line. That's going to be the slope. That's the derivative, right? If you look at this line here, that's a negative slope. Okay? When you have a negative slope, that means that the function is decreasing. So negative slope, I'm just going to put negative. Negative slope means f of x is decreasing. Okay? So this is a negative slope, negative slope, negative slope, negative slope, negative slope, negative slope, and then the slope is 0. That's what we mean here when the derivative is 0. Here the slope is 0. So that means that this here is a critical number. And you might say, well, what is the number? So this number here is x equals 0, right? X equals 0. And we're always talking about x. We don't really care about the y. And then what happens? Okay, after 0, then you start to go up. So this is a positive slope, right? So positive slope, function increasing. Okay? So here the function is increasing going that way and the function is decreasing going that way. This is called a critical point or a critical number, better, right here, because it changes. So it's like a critical point means that you were going down and all of a sudden you stop going down and you start going up. That's a critical number, plain and simple. Cool? Okay, so I think that the best way for me to teach this is with an example. So let's do example 1. Okay, so I have y equals negative 2x squared plus 8x minus 2. Okay, and let me write the steps on this side. So these are the steps to find a critical number. Okay, steps to find a critical number. Number 1, take the derivative. Okay, y prime equals negative 4x plus 8. Cool. 2, simplify. This, I put this simplify. Oh, by the way, and these are my steps. I'm gonna put Tn, Cisneros Tn. Okay, simplify. There's nothing to simplify here, so we're good. I put that just in case you have a multiplication or you have to divide something or whatever. 3, you set it equal to 0. So now I have negative 4x plus 8 equals 0. 4, solve. Okay, so okay, so I'm gonna do minus 8 minus 8 cancels out. Negative 4x equals to negative 8 divided by negative 4 divided by negative 4, cancel. X equals, what is that, 2? Did I do this right? Interesting. Okay, cool. Yeah. All right. So this is a critical number. All right. And then you must ask, are we done? Now remember, we're trying to find a max, a min. This one is a minimum, right? Remember, when x squared is positive, you get a minimum because it's going up. If you have the x squared is negative, the coefficient is negative, that means that the function is going to look like that. So we already know that we're going to have a max here. The max happens right here. So how do we find that? So we're going to create a table. Okay, this is how we always start a table. Look, since here they didn't give us any intervals, we're going to start with negative infinity. Okay, sometimes they tell you from 0 to 100, then you will start this at 0. But since they didn't give us an interval, we can start with negative infinity. And then we close it at the critical point. So this would be 2. Okay? And then you're going to put this number again here. That's where you're going to start the next interval. Sometimes you might have more than one critical point. So you will put the next one here. And you always go from smallest to greatest. So here we don't have any other critical points, so we're gonna close it with positive infinity. Okay. The next thing, you're gonna choose a number. I'm gonna put it here. Choose a number inside interval. Your number has to be inside your interval. You always try to get the easiest numbers possible. So if you have between negative infinity and 2, I'm gonna choose 0. That's the easiest number. Here, there's no, I mean, the closest one to 2 would be 3. These numbers have to be in between these two, inside the interval. I always get the same question. How did you come up with 0? You choose these numbers. You choose them. Nobody's going to tell you. You choose them. The only requirement is that this number is inside this interval, and this one is inside. Every number has to be inside every interval. Okay, then we're looking for the sign. How do you find the sign? You plug in your number into your derivative. Okay, plug in your number into your derivative. Let me write my derivative here so I can have it close, because I have it all the way over here. So y prime equals to negative 4x plus 8. Okay, I'm gonna plug in 0. When I plug in 0, negative 4 times 0 goes away, so I get positive 8. Okay, I don't care about this number, I care about the sign, so I'm gonna put plus here. Okay, and then I'm gonna choose a number, between 2 and infinity. We already have it, which is 3, so I'm gonna plug it in here. So negative 4, can you guys see? My bad. Okay, so plug in your number. I plugged in 0. Negative 4 times 0 gives you 0, so you get positive 8. Okay, I don't care about the 8, I care about the positive, so I put the positive here. Okay, now I'm gonna plug in 3. So negative 4 times 3, and I'm just doing this so you guys can see, but I usually do it in my head. Negative 4 times 3 is negative 12 plus 8. Negative 12 plus 8 is negative 4. Again, I don't care about the number, I care about the sign. So this is negative. Okay? Cool. So basically we're done. We already have what we need. Look, what I like to do is kind of to do like a visual representation. This plus means that your derivative is increasing. Okay? So increasing. Okay? It's going that way. It's going up. Okay? Remember we found 2? So basically 2 is right here. So what we just found out right now is that 2 is a max, like this. Okay? So we know we have a relative max at x equals 2. How do we know? We just found it right here. Oh, look. What happens here? The negative means you have a negative slope. That means that it's going down. What does that mean? The function is decreasing. Okay? Negative slope. Cool? Positive slope, negative slope. Okay? So in your answer, remember, they're asking you for the relative max. Do you have a relative mean? No. You don't have to write it. Do you have intervals where the function is increasing? Yes. So we say increasing and you put the interval. In this case, we're looking at this, increasing between negative infinity and 2. And then that's it, right? Sometimes you would have, this function might go like up, down, up, down. So you're going to have like 2 or 3 intervals where the function is increasing. So you would put negative infinity to 2, comma, and then for example like 3 to 7, comma. So you write all the intervals where the function is increasing. And then you write the intervals where the function is decreasing. In this case, it's just from 2 to infinity. Okay? You have to have all the increasing and all the decreasing. If you have like another interval and you didn't write it here, then your answer is wrong. You have to put all of them here. Okay? Sometimes some books require you to plug in your x because they want an actual coordinate. So here in the max, they want the actual coordinate. How would you find the coordinate? So the relative max, 2, comma, how do you find the y? Well, you plug it in your original equation. That's going to give you your original equation is this one. So if we want to plug in 2, so that's going to be 2 squared, that's 4, times negative 2, that's negative 8. So we have negative 8. 2 times 8 is 16, plus 16, minus 2, that's negative 10 plus 16, that's positive 6. Okay? So this is your relative max. This is a good idea to have it like this and have the coordinate, and then increasing and decreasing. So this is what we're looking for in this type of problem. Okay? So relative max, 2,6, and then increasing and decreasing. Cool. It's okay. Okay, let's go to the next one. Example número 2. Again, I'm not gonna write what the problem is saying. Remember, we're just finding relative extrema, that's maximum minimum, and then increasing or decreasing. That's what we're trying to find. Okay. So example 2 says y equals negative x squared over 2 minus 2x. Okay. Okay, so the first thing I'm gonna do is follow my steps. I'm gonna take the derivative. So y prime is gonna be equal to, I bring down the 2, that cancels, so it's negative x minus 2, right? The 2 cancels the 2, alright? What's next? Simplify, there's nothing to simplify, set it equal to 0. Okay, solve for x. So I can just put the x here, so that means that x is equal to negative 2, right? Okay, again, this is a critical number, right? Critical number. I just like to circle it so I don't lose it because you have to find it again. Let me do the chart here. Again, did they give us an interval? No. So how are we going to start it? Negative infinity to what? To negative 2. Do we have another critical number? No, we don't. Okay. So we're going to put negative 2 and then that's it. No other numbers. Oh, remember. So negative infinity to negative 2, that's your critical number. And then you start your next interval with the same critical number. If you have another one, then you would put it here. Since we don't have anything, we just put infinity. Okay? Choose your number. Between negative 2 and negative infinity, negative 3. Choose your number here, 0. Cool. Plug it in your derivative. Let me put it here so we don't make a mistake. Negative x minus 2. Plug in negative 3. This is negative 3. That's going to be positive 3 minus 2. That's positive 1. Remember, we only care about the sign, so this is positive. Okay? Plug in 0. Plug in 0 there. That goes away. You get negative 2, so that's negative. Okay? What did we just find out right now? Your function is increasing, and then it stops. So increasing, and then decreasing. Okay, so that means that this is a max, right? Max. So where's your max? At negative 2. So relative max at x equals negative 2. And then remember we want to have the coordinate, so plug it in. Look, I'm going to put negative 2. Negative 2 squared, that's positive 4. But you have a negative, so 4 divided by 2, that's negative 2. And then plus 4, that's going to be positive 2. Okay? Relative max. Do you have increasing intervals? Yeah, increasing. Negative infinity. Oops, I did a negative infinity to negative 2. Decreasing. Negative 2 to infinity. Beautiful. Cool. You see how easy this is? And the reason why look, in the first example, I went super slow so you guys can get the hang of it. Now I'm going a little bit faster, and remember you can always pause the video, copy everything. There's some people that like to watch the whole thing and then they stop the video and they copy it. Some people like to be doing it next to the video. You could do it however you want as long as you get it. Cool? Okay, I want to do a fun one, but I can't find one. Well, we'll see right now if we can find a very interesting one. Let me do another easy one. This is the whole thing we're gonna do today because I don't want to get people confused. Let me do this one. Y equals. Oh, do I have a cube? No, I don't have a cube. Okay, let's do this one. I have negative 2x squared Is that the one we did? No. Oh, it's close. Negative 2x squared plus 4x minus 4. Okay? Find the derivative. Y prime equals, that's what? Negative 4x plus 4, right? Piece of cake. Set it equal to 0. That's going to be 4x. That's going to be x equals 1. So this is your critical number, right? Cool. Table. We're going to start it. Again, there's no interval. Negative infinity to what? Well, you only have a 1, okay? Close it. Open the next one. Use the same number. Do you have another one? No. Okay, close it. That's it. Choose your number between 1 and infinity. Negative infinity is here. Between 1 and infinity, 2. Plug it in. I'm going to plug it in here. So if you plug in 0, that goes away, so you get positive 4. So plus. Plug in 2, you get negative 8. Plus 4, you get negative. Again, going up, stop, going down. Increasing, max, decreasing. Okay? Again, so I'm not going to plug it in because you guys can do that. So relative, you can do that on your own. Relative max at x equals 1, right here, x equals 1. And then increasing from negative infinity to 1 and decreasing, oops, I need to remind me guys that I need to put the paper up. So relative max at x equals 1, right here. And then increasing from negative infinity to 1 is going up. And then decreasing from 1 to infinity. It's okay, right? Decreasing from 1 to infinity. Okay, let me look for another awesome problem. So, give me 1 second. I'm trying to find a cool problem. Sorry, guys. Oh, let's do this one. This one is easy, but we haven't done something like this. Okay, this is what, example 4? I have f of x equals x cubed. Okay? Find the derivative. That's what? 3x squared. Okay? Set it equal to 0. That's what? That's going to be just x equals 0, right? Divide by 3, square root, so x equals 0. Again, this is your critical number. Okay? Notice that we only have one critical number, so we're going to start from negative infinity to 0, and then 0 to infinity. Cool? Number, negative 1, number 1. Plug it in. I plug in negative 1 here, I get positive. And I plug in 1 here and I get positive. This is interesting. Look, your function is going up, and then what happens? So it got to 0 somehow, but it's still going up. Okay? If you remember, if you want to graph y equals x cubed looks like this. So it gets to 0, and then it goes like that. And remember, let me take out my awesome ruler right here. My awesome ruler. The derivative is positive, it's going up. So the derivative is positive, derivative is positive, derivative is positive. At this point here, the derivative is 0. Okay? And then what? The derivative is still positive. See? Let me do it on this side. See, the derivative is positive all the way. So it doesn't, instead of going this way, instead of going down, it looks like it's about to start going down, but then all of a sudden it keeps going up. Okay, awesome. So guess what? Is there a relative mean? No, because the relative mean happens right here, right? When it's negative and then 0 and then positive. This is a mean. A max is when it's positive, 0, well, I'm going to put 0, 0, and then negative. That's a max. Here we have plus, 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 plus. So guess what? So no max, no min, and then increasing. Oh, this is a good example. Look, increasing from negative infinity to 0. You always have to put the interval because your interval stops at 0. We're gonna put negative infinity to 0, comma, and then 0 to infinity. Okay, so this is our answer. Let me see if I find another awesome one. Okay, I found one. Yeah, let's see if I remember how to do this one. This is example 5. I have f of x equals x times x minus 1 quantity squared. Oh Lord. Okay, look. This is a product rule and a chain rule. So for the product rule, f prime g plus g prime f, and then you'll remember the chain rule, right? Okay, so let's do the product rule. The product, and this is f, and this is g, the whole thing, okay? The derivative of f is 1, so I'm just gonna copy g. So this is f prime. So f is 1. I'm gonna write it just so you guys see the derivative of f, and then the copy g. So this is x minus 1 quantity squared. I have a plus. Now take the derivative of g. Let me do it here. So bring down the 2, copy the inside, subtract 1, which is just 1, and take the derivative of the inside, which is just 1. So basically here you have 2x minus 1. Okay? It's okay? Okay? Awesome. Okay, let's see. How do we do this? We took the derivative. Remember how we said that it would be easier if we simplify? Let's see. Look at this. What about if I just put equals 0? If I plug in a 1 here, I get 0 here, right? If I plug in a 1 here, I also get 0. Okay, so I have x equals 1. Is there another number? If I plug in negative 1, I get negative 2. Nope. So I just have 1. Interesting. Did I miss something? I did miss something. Here, I got the derivative of g, but I didn't copy f. So f goes right here, which is x. Okay. Does 1 still work? Okay, plug in 1 there, you get 0. Plug in 1 here, you get 0 times 1 is still 0. Okay. Plug in 0 here. If you plug in 0 here, you get negative 1, positive 1, you get 1. And if you plug in 0 here, you get 0. Huh, interesting. Let me see if I can find it, because I have another answer. Let's do this. Look, x minus 1, x minus 1, x minus 1. So let's work this out. This is going to be x squared minus x, so minus 2x plus 1. And then this is going to be plus 2x squared, right? X squared minus x minus 2x. Okay? Put everything together so we get, can you guys see? Yeah. 3x squared, 3x squared. I have minus 2x, that's minus 4x plus 1. Okay. Remember, set this equal to 0 and then factor. Okay. So when I have a number in front of the x squared, I just put it here. This is x, this is x. If this is a plus, you write this sign here and here. How do you get 1? Well, you can only get it by doing 1 by 1. Okay. So now, let's see. If I get 3x times negative 1, I get negative 3x, and then this is negative x, that's negative 4x. Okay, so we got it right. Cool. So here I found, so this is equal to 0, right? So that means that x is going to be equal to 1, but also x is going to be equal to 1/3. How do I know this? Look at this. 3x minus 1 equals 0. So plus 1 plus 1. 3x equals 1, divide by 3, divide by 3. X equals to 1/3. Cool. Yeah, you know what, if we graph this, this is going to be x squared times x is going to be x cubed. So our function is going to look something like this one here. Not exactly, but this is how x cubed looks. So you're going to have, this would be considered a max and this would be considered a min. Okay, I'm going to kind of graph it here. Look. Well, you know what? Let's do the, so we found these are our critical points, our critical numbers. Let me see how much time we have left. Okay, we have plenty of time. Okay, let me do my table right here. I'm gonna start with negative infinity. Negative infinity. Which one's smaller? Well, 1/3. So I'm gonna put 1/3. I'm gonna close it. I'm gonna open it again. Remember, same number, put it here. Now we have two numbers. Okay, so I'm gonna close it with a bigger number, which is 1. But then I have to go all the way to positive infinity. So I'm gonna write this number again. Since I don't have any more critical numbers, then I close it with infinity. Okay? Now time to choose. Lucky look. 0. Between 1/3 and 1. What about 2/3? Is that, let's see. If we have 0 and 1, and we do this 1/3, 2/3, 3/3. So this is 1/3. So 2/3 is bigger. And it's between that. Okay, so we're going to choose 2 or 3. And then between 1 and infinity, 2. Okay, so now we need to plug in. Remember, these are the numbers we chose. Okay. Oops, numbers. These are the numbers. Alright, so let's plug in 0 in our derivative. Where's our derivative? This is our derivative here. You want to plug it in here? Fine. Plug in 0. You get negative 1. Negative 1 squared. You get positive 1 times 1. You get 1. And then you plug in 0 here. Everything goes away, so it's 1. So this is positive. Now plug in 2/3. If you plug in 2/3 here, you get a negative, but that's still positive. And then here, you get, oh, let's do this. Let me do it here. So 1, and then, well, whatever this is going to be, well, no, you know what, let me do it. 2/3 minus 1 squared. And then I have plus 2, and then 2/3 minus 1 times 2/3. That's this. Okay. Alright, let's do this one. So plug in a 3, 3, 2 minus 3 is 1. So negative 1/3. Negative 1/3 squared would be 1 over 9. So 1 over 9 plus, look at this. This is going to be, let's do it this way. That's going to be 4/3 minus 2. 4/3 minus 2. And then times 2/3. That's going to be 8/3, no, see, 8 over 9 minus 4 over 3. We need another 9 here, so times 3 times 3. Negative 4. Okay, that's negative 12. Negative 12 plus 8, that's negative 4 over 9. So plus negative 4 over 9. Okay. Look, so 1 minus 4, you get negative 3 over 9. Negative 3 over 9. So this is negative. See, the only thing about this type of problems is that you gotta sometimes, or many times, you gotta work with fractions to get this sign. And then plug in 2 here. 2 minus 1, that's 1, so this is 1. And then this is 2 minus 1, that's 1, times 2 is 2, times 2 is 4. So all positive, so this is positive. So what did we just find right now? Look, let me do it here. Positive, that means increasing, you get to 0, and then you're decreasing, and then you increase again. Okay? So increasing, decreasing, increasing. Okay? This one here, when it changes from, I have it here. Remember, this is plus to minus. Plus to minus, there's a max. So max, x equals 1/3. And then decreasing to increasing is this one. So there's a mean. Mean, x equals 1. Okay? Now we need to do the intervals of increasing. So increasing, negative infinity to 1/3. Negative infinity to 1/3. Comma, there's another one. 1 to infinity. Cool? Do you have decreasing? Yeah, we do. It's this one here. So decreasing from 1/3 to 1. Okay? And we are done with that problem. Cool. Let's see if I can find another one. I did. All right, let's do another one. See how fun this is? Who would have thought that calculus is super fun? All right. Example what? 6. Example 6. Okay, I have f of x equals to x cubed minus 3x squared plus 1. Again, we don't have any intervals. Cool. So take the derivative. 3x squared minus 6x. Set it equal to 0. Okay. We can take out an x and a 3. 3x times x minus 2. Is that right? 3x times x, 3x squared. 3x times negative 2, negative 6x. Okay, good. Set it equal to 0. Cool. That means that this x here, anytime you have an x outside the parentheses, that means that x equals 0 will work. So you have a critical number at x equals 0. Look, how do I know? Well, plug in 0 here. 3 times 0 is 0. Whatever you get here, it doesn't matter because you're going to have 0 times whatever, like times negative 2. What is that? Well, 0. Okay. Now plug in, what was it? Oh, what about here? How do you make this 0? Well, since this is negative 2, we need this to be a 2. So x equals 2. So see, now we have another time we have 2 critical numbers. Now let's do our tables. Again, negative infinity to what? 0. Okay, close it. Open the same number. 0 to what? To 2. Okay, close it. Open. What's next? Well, the same number here. This one, put it here. Do we have any more? No. Okay, we close it with infinity. All right. Choose your numbers. I have 0 here, so -1. Between 0 and 2, I'm going to choose 1. Between 2 and infinity, I'm going to choose 3. Mister, how do you choose the numbers? You look at this one and pick a number inside here. See, you can I choose -1 million? You can choose whatever number as long as it's here. Okay. Would I choose -1 million? No, because it's going to be super difficult. Will you get the same answer? Yes, you will, but it's going to take you way longer. That's why we choose the easy numbers, okay? Plug the numbers in your derivative. Plug in. You can use either one of these because this is the same thing. Let's choose this one. If you plug in -1 here, you get -3. And then if you plug in -1 here, you get -3. So negative negative gives you a positive. So this is positive. If you don't understand what I just did, actually plug it in your own paper. Plug in -1 instead of the x's and do the math. Plug in 1. 1 minus 2, that's -1. This is going to be positive, that's going to be negative. Plug in 3, that's going to be positive, that's going to be positive. Okay? What did we just find? Increasing, max, decreasing, mean, increasing. Increasing, max, decreasing, mean, increasing. We're done. Okay? Max. Oh, remember we put relative max at x equals 0. Okay? Relative mean at x equals mean 2. Okay? Increasing, I have negative infinity to 0, comma, this one too, 2 to infinity. Decreasing is this one here. Okay, piece of cake. I think that's about it. Do you guys want to do more examples? Yeah. No. Yeah, I think we're good. This should be good. Let's see how long that took. We are at 42 minutes. Alright, cool. Alright guys, so I'm gonna upload this video and make sure that you do the assignment, okay? If you have any questions, you guys can text me. For the rest of the people, you can send me a message through YouTube. Peace.